Okay. Now, I know this topic is called the antiderivative, but it's not as evil as it sounds. It's just the derivative, but backwards. So let me give you the idea here. We start off with something like x squared, and we calculate the derivative of it. What's the derivative? 2x. The antiderivative is going back to the original. So the antiderivative takes 2x to x squared. Okay, so you can draw this little diagram here. Derivative would take x squared to 2x, and then antiderivative would take 2x back to x squared. Although there is a complication that we'll look at now in a minute. Yes? Yeah. Now let's look at this complication. So let's imagine for the moment I had x squared plus 1. What's the derivative here? 2x. And what's the antiderivative of 2x? Well, this is the thing. Previously I said the antiderivative of 2x is x squared. But if I say it's x squared here, it doesn't quite take me back to the original, does it? Yes. And this is the problem with antiderivatives. In other words, there's always some constant number in the answer which you don't know, which we call plus c. And we can't really know what that is. We can work out later what it is, but right now we can't. So for example, x squared, the derivative is 2x. X squared plus 1, derivative is 2x. And you can see what's happening here. X squared plus 2, derivative is 2x. So if you start here, you have no way of knowing which one to go back to. So you just say, oh, antiderivative is x squared plus some number. We don't know. And this is true for all antiderivatives. Okay, so write this down and we'll look at the rules now. Okay, so let's look at the rules here. We can actually work out the rules for ourselves by thinking about the derivative rules but backwards. Oh, and I should also say, what is the symbol that means antiderivative? It's this symbol here. So if you want the antiderivative of something, you just put it inside of this symbol. That means antiderivative. So for example, 2x, we already know this one. What is it? X squared plus c. Okay, so this, write this down. This is the symbol that means antiderivative. And if you want to think about it in more detail, this symbol here means antiderivative, and then this symbol here tells you what the variable is. So you know previously you have dy dx. Which one is the variable? The y or the x? The x is the variable that changes. So the dx here tells you what the variable is. Normally x, but could be any letter. So like for example, you could say 2t dt would equal t squared plus c. Just a letter. Okay, let's look at the rules now. Okay. As the name suggests, the rules will be pass it up. Come on, give it to Sadiq, pass it up. There you go. Thank you. Okay, as the rules suggest, it's just the derivative rules but backwards. So what do you do for a derivative of xn? So what would be the rule here? You take down the power and take 1 from the power. No, look up, listen carefully. I know listening's a little bit, so just listen carefully. For derivative, you take down the power and then you take 1 from the power. So if I do this backwards, what would be first? The power. And instead of taking 1 from the power, what do you think I do? Add 1. And instead of multiplying in the front by the power, I divide. So it's exactly opposite. So this is the rule for the antiderivative of x with a power. You increase the power by 1 and you divide by the power. So that's your first rule. Got that? And let's do a very small quick example to check. So, what is the power here? 1. So if I increase the power, what do I get? 2. And then what do I do with that? Divide by 2. I'm left with x squared plus c. No surprise, because that's what I had on the previous page. So you don't even have to write that down, but that's just me showing you that it works. Okay, that's x power n. What is the derivative of sine x? Cos x. So then the antiderivative of cos x will be sine x.
Minus.
Nope, sine. Now what is the derivative of sine x? Oh, sorry, I said that wrong. What's the derivative of cos x? Minus sine x. So the rule is, if it's sine, if it's cos, you change it to sine, and you change the sign. So if you do that backwards,
It's minus sine.
no, it's right, it's sine, yes. This would be minus cos x plus c.
So it's the opposite of the previous one we did.
Yep. Now,
Why didn't you make the sign minus?
well, think about it like this. What's the derivative of sine? It's cos. So it is right, because here to here is anti, so here to here should be derivative. Yes? No? Look, it doesn't really matter. You just need to know what the rules are. Okay? Right. E power nx. What do we do here? Derivative. You just bring the n down in front, and that's it. So what do you think the antiderivative rule would be? Instead of multiplying by n, we divide by n. Okay. I don't know if anybody remembers this, but does anybody remember the derivative of tan x? 1 over cos squared x. So therefore the antiderivative of 1 over cos squared x is tan x. Yes? The last one I have to give you is not, it's a little bit related to one I gave you for the derivative, but you actually haven't seen exactly it for the derivative. So this one here is given to you more as just a rule. And it's if you want to find the antiderivative of 1 over ax plus b, it will actually be 1 over a log ax plus b plus c. So in some way, this is kind of a new one.
It's only in the empty. Doesn't happen.
We don't really have a derivative one to compare it to yet. Yes? Got that? Yes? Scroll up. That's all of them. Okay. Let's have a look at some examples. I'll do one from each. What? 1a. Okay, what is the rule here? No. Please, focus here. Okay, I increase the power, so what's the power now? 2. And then I divide by 2. Now this one might be a little tricky. What do you think the antiderivative of 1 is?
X.
It's x, yeah. It's the opposite of the other rule. What's the derivative of x? It's 1. So the antiderivative of 1 is x. Or in other words, if you want to think about it like this, if you just have a number, its antiderivative is 3x, and that's really it. Okay, plus c. Or even, again, another way to think about it is, instead of writing 1, I could write x power 0. And then I increase the power, which is 1, and then I divide by 1. Whatever way you want to think about it. Okay, so what does this equal?
7.
Finished. Yes? Okay. Now let's look at 2a. Let's actually do 2e. Make it a little bit more difficult. So you want antiderivative of 3 over x. And I'll make this really, really clear for you. That is equal to 1 over 1x plus 0. And the reason I wrote it like that is to make it very, very clear I'm using the last rule in your tables. What's the a here? 1. And the b? 0. And you have this multiplying number in front, which is fine. It just multiply the answer by 3. So what's the antiderivative here? What's the rule? It's 1 over a, yes, log ax, which here is 1x, plus b, which is 0, plus c. Or in other words, oh, and don't forget there's a 3 multiplying your answer as well.
So the first number on the top is a.
Just before you go on, somebody will ask me, why did I not multiply the c by 3? I don't have to. The c just represents some unknown constant at the end. C, 10c, a million c, whatever. It's another way of just writing plus constant at the end that you don't know. It's unnecessary to multiply it by 3. It's still a constant you don't know. Okay, you have that taken down? And now I'll do 3a. Okay, 3a. So I tell you that derivative equals 6x plus 2. So if I tell you the derivative is 6x plus 2, how do you think I could find out what the original is? In other words, how do you think I'd cancel a derivative? With a antiderivative. Right? Like, just think about the language here. You cancel a derivative by using the antiderivative. So the derivative equals 6x plus 2. So if I put an antiderivative on both sides, I'll write on the next line. So, look at the left, derivative and antiderivative. What happens?
Cancel.
Cancel. So I'm just left with, what am I left with here? fx. Yes, does this make sense? The derivative and the antiderivative cancel each other. Yes? Give me an example of two things that cancel each other in maths. Log x and ex. X squared and square root x. Multiplying by 2 and dividing by 2. Derivative and antiderivative cancel. Now, what do I get on the right? 6x squared over 2 plus 2x plus c.
Do I have to put the c?
Yep, you will lose 1 mark if you don't. So you get fx equals 3x squared plus 2x plus c. But in this question here, 4x? No. Where? So, in this question here, there is a way to find the c because I give you an extra piece of information. Have a look at the question. What else do I tell you? You know that f of minus 3 should equal 32. This is actually enough to help you find the c, because you need f of minus 3, which would equal 27 minus 6 plus c. You need that to equal 32. You see how I got that? What did I do here? Replace the x with minus 3, and I got this. Yes? So you get c equals, what's it, 12? Hang on. 21, 9, 11. Yes? Check on your calculator. Yes, no?
Yes.
Yes? Okay. I don't think that's right at the back. The C is off. Now, listen, good news is number 3 is not in the exam. No, it wasn't that difficult now, was it? No. But, hey, but number 1 and 2 is definitely in the exam. Every single year in section A and in section B. And it's probably, you can see for yourself, they're not very long questions, right? They're only 2-3 lines.
Section A.
Section A and in section B. So there's no reason you shouldn't get full marks because you have the table book, the formula book in the exam as well. So provided that you can read and use the calculator, which I know a little bit, but you should still get full marks in this. Okay. Right, so I'll just need you to do 1 and 2, which you can start now, and
Let's scroll down a little bit.
okay, to where?
Which
Yeah.
number?
Yeah, 1 and 2.
Last one.
No, these are really short, so I'd say, yeah. No, that's too little. What's wrong? Can you please stop being dramatic? Please. What's the problem? Is there a problem? No, okay. Can you do the first and last 4 in 1 and 2? Yes, I'll say that again. The first 4 and the last 4 in number 1 and number 2. Got it? You wrote this down?